Great. Julian, we are live. Hi. Hi, everyone. I hope everyone is doing great. It's been quite some time that we haven't met on YouTube live. And we are again super excited to have you all here again. And this time we have Professor Julian with us. I don't really need to give a formal introduction about him to you all because you know him by now very well. And you know how awesome he has been taking the live doubt sessions or the previous sessions that we had with him, and also you see him proactively responding to the learners queries on Slack channel and bunch of other places. It's very inspiring to see him take this up despite the hectic schedule that he has at the moment. And as you all might be aware of it, this session will be a hands-on session where Professor Julian will use a real data set to perform sentiment analysis on Amazon customer reviews data set. And yeah, I'm super excited for the session. With this, I'll hand it over to Professor Julian. Julian, you may go ahead. Yeah.
Thank you, Chanakya. Thank you for having me. Good morning, good afternoon, and good evening to everyone. Nice to talk to you again. So this week and this session, we are going to have an introduction to NLP with sentiment analysis, as Chanakya was introducing. You already know much of my career. So again, I am just a cybersecurity specialist, computer science engineer, and electronics engineer who works in several fields, including NLP, cybersecurity, steganography, cryptography, and other fields. We will be talking in this session about natural language processing. So we will be having an introduction at first. The NLP challenges is going to be our second topic. This topic is going to be very important because it's the main reason for talking about NLP. Then we are going to have some fundamentals. We are going to see how cyber attacks and how cyber cryptography practices are included into NLP. We are going to see some NLP pipeline, some data preparation pipelines. Then we are going to be looking to the applied data science topics regarding the NLP applications. Then we are going to have the use case where we are going to see how this Amazon dataset is interacting with the customer reviews, and we are going to perform a sentiment analysis on the Amazon's customer reviews. And then we are going to have some conclusions and future work. So first of all, we are talking about natural language processing, and natural language processing can be divided into two main topics. So we can talk about language and about processing. So when we mix these two topics, we are talking about computer science, which is the processing step and pre-processing, post-processing steps. And we talk about language, specifically about natural language. So how we are interacting. So when we come up with this mix, we have a very interesting topic, which is the computer science applications to the language. But what is it about the language? So language is generally a system that let us communicate with each other, considering a context. And this is very important because we are already involved in a context, and our frame is going to be a context. So it can be a cybersecurity context, it can be whatever the conversation context is. And there are combined principles that support this language. So the language tends to be structured somehow, but we are going to see this is one of the main challenges. Second, the language can be presented in different ways. So we think about text when we talk about language, but there are other forms of languages. So the speech is also a language. We are talking right now, and you are interpreting my words. So this is a sort of language too, because we are using a system to communicate. This is very difficult to process too when we talk about natural language processing, because we are talking about processing the speech. We can have signs. So we generally talk about image processing and understanding what the text is in the image. We can talk about fingerprint detectable characters. So this is also a very interesting work. This is also among the language techniques that we might have. And we might think about others type of languages. So everything can be framed into the language. and everything can be processed using natural language processing. So we will be focused on text, how to process the text and how to communicate and how to understand by computer science practices the text that we are writing. And in this case, it's going to be the text that some customers are writing on Amazon reviews. Third, the natural language processing, as I was saying, allows us as humans to have an understanding and interpretation of the communication with the machine. So we are already talking about humans and machines. So that is why we are calling natural language processing, and that is why we have these two main components, the one regarding the computer science and the one regarding this system of communication that is called the language. What are the main challenges for us when processing the language? There are two main challenges. The first one is that the text generally is unstructured and is highly dimensional. What is the difficulty and the challenge with this main challenge that we are having here? So imagine that we are interpreting this book. So it's 100 Years of Solitude by Gabriel Garcia Marquez, a Nobel Prize from Colombia. I'm a little biased about Colombia because I'm Colombian. So this is the example. So let's think about any book. So you want to perform certain sentiment analysis or whatever the language processing task is to the book. So how would you do that? So first, you can process the text using the characters. So you might be aware that the book is huge in words and characters. So I am telling you here that the book has more than 1 million characters. And hence, if we want to process this 1 million characters, there will be a 1 million dimensional vector. So imagine this 1 million dimensional vector. So it's going to be huge. And this is just one book. So if you want to perform the same tasks, perhaps for a database with 100 books, it is going to be 100 times 1 million dimensional vectors. So this is a lot of data to be processed. And of course, you're going to take a while processing this data. So this is the main challenge in NLP. Always we have highly dimensional data to be processed. If you want to process words, it is also being difficult because we have more than 100,000 words in the book. So this means that we are going to have 100,000 vectors that represent the book, and then we will need to analyze each word. So it is similar to the challenge of interpreting the characters as interpreting the words. And you might think about, well, I can abstract everything and then I can interpret the sections generally. Yes, but the sections have any context. So you're interpreting 20 sections of the book that have extremely complex language. So this is going to be also a very difficult task to do. So this is one of the main challenges for us. And we are going to see how certain data science practices can be applied in order to diminish the impact of this highly dimensional space that we are creating when interpreting the language. Second challenge, we have the context. So everything nowadays and regarding the data science practices and NLP is context dependent. We have been saying in all of the sessions that we always have to be aware of the context. And in NLP, there is no exception. So we are framed in a context. So I'm going to put this example. So imagine we are going to interpret the term compact. So we just have to interpret this word, just one term, compact. So if you want to interpret a compact term, there are several uses in English for this term. So they're called homograph terms because they are written exactly the same, but the meaning is different. So we might think about compact with all of these different applications and terms. So it might be a synonym of small. So something is small, we say it is compact, but we might be talking about compressing something, or we might be talking about something that denotes firmness, or we might be talking about a small case for makeup, or about a car, or about a cassette, or about something that is metallic. So we have plenty of different contexts in here with the same word. So I would like you to think how are you interpreting the word when I am talking to you? So it totally depends on the context. So you will be analyzing when I am telling you the word compact in certain context, if I'm talking about a car or if I'm talking about the makeup. So both of them are very different. You're not going to use a car for making up your face, or you're not using a makeup case for driving to home. So everything is context dependent in here, and we have to be aware of the context in order to interpret it and then to give a meaning to the word. So this is very important when talking about NLP. So both challenges are very difficult to address depending on the data science practices. So first challenge again is a highly dimensional space, and second challenge is the context. And we are going to be addressing both challenges when talking about the use case. So what is the pipeline that we follow when we talk about natural language processing? So the general pipeline is the same. So generally, we are talking about the same pipeline as data science. So we have a business context, and this is very important, as we have seen in the second challenge. The first step is acquisition. It is the exact same step as in data science. We are collecting the data so that we can process this data according to the business context. Then we make some data preparation techniques. So we structure, clean, and enrich the data. We are going to see that this step is pretty different from a traditional data science scope. Then we explore our data, as in data exploration or exploratory data analysis. In NLP, this practice is just the same. We are exploring our data, our text. Then we use this modeling stage. So we propose some machine learning models or deep learning models in order to predict something in the text. And then we validate the model so that we can visualize and make decisions. So this is the general data science pipeline. And you can see that for NLP, it is the exactly same general pipeline. So we are following the same 6-step pipeline. But what about the data preparation step? So this is pretty different from a traditional data science practice, because we are going to be doing here several steps in this phase of data preparation. So we might be talking about the text. So imagine there is a text that serves as an input. So we are analyzing the book. So the book is going to be our input. The first thing we have to do is normalize and standardize our text so that we can process the words. Second step, we need to split the sentence. It might be because we want to interpret the sentence separately. It might be because we want to interpret the words, but we need to split the sentences generally by separators that are maybe dots or maybe a commas or whatever the separator is. Then we need to tokenize the word. So when we talk about tokenization, we are talking about general separations of the words of the sentences. So the sentences are composed by words, and we need to separate those words so that we can analyze the words separately. This is the tokenization step. Then we want to analyze what the tags are. So we have plenty of words in our space of sentences, and perhaps you might think about words as verbs or as nouns or as adverbs, as adjectives. So we want to analyze what the different tags are from each of the words. This is the part of a speech tagging. And it is a quite difficult practice at first, because we are already implementing here machine learning models so that we can tag the words. So you might be thinking about words expressions and verbs expressions. So for example, I am telling you that I am running, and tomorrow I tell you that I run, and yesterday I'll tell you that I will be running. So those different expressions of the verbs needs to be interpreted as the same. So generally we want to run. So this is a very important test when we talk about part of a speech tagging. When we talk about stemming and lemmatization, we want to extract this general root of the word. So we have already interpreted that all these words are verbs. Now we want to extract the root of the word. We will see this in the use case. Then we come up with a syntactic analysis. This is a quite difficult task because we want to check the text for meaningfulness. So once we have the tag, once we know that is a verb and we know what the root of the word is, we need to analyze that word according to the context. So this is one of the key steps because of our second challenge that involves the context. So we will be analyzing what the meaning of the word is. So if I am talking about compact, what is the meaning of that compact word framed in our context? And the final phase is going to be word sense disambiguation, also a very difficult phase at first, because we want to determine the meaning of a word relative to the context as we are doing the syntactic analysis. So these two final steps are key for us in order to interpreting the language in our natural language processing approach. We will not be following this exam pipeline in the use case because it's going to be pretty difficult to express the last two phases. So we will be doing the first four phases. Where can we implement these NLP practices? So natural language processing applications are generally built again on top of EDA, regression, classification, supervised and unsupervised learning. So we are using the exact same pipeline of data science and the exact same applications that we have been seeing before, using the exact same classifiers. But the key here is this data preparation step. So before doing any modeling, we have to prepare our data using these steps that we are seeing here in this data preparation phase. This is the key for us in NLP. Examples of these applications of natural language processing, we might be seeing machine translation when we translate something on Google Translator or whatever the translation API is. So this is a very important application because we are translating the documents. And for translating the documents, we need to interpret the context. We might be talking about information retrieval. So once we are searching something in Google, we know that Google is throwing us specific results according to our context, and that my results are different from yours because my context is different from yours. So this is everything about information retrieval, and we need to apply NLP practices in order to interpret the language that you are using according to your context. We might be using sentiment analysis as we are going to use in our use case. So we want to analyze the sentiments, including in customer reviews, for example. Maybe for decision making in a key context, we might be talking about marketing or about production or about whatever advertisement or context is. We can perform NLP practices in this fourth example for spam filtering. This is just a very common example where we apply NLP techniques in order to filter what the emails are according to spam or non-spam. So this is basically a binary classification approach using NLP techniques. The same can happen using phishing. So we are detecting what the phishing attributes and features are so that we can select which emails are not from phishing and which emails contain phishing. So again, it might be a binary classification approach using NLP and machine learning techniques. And we can also perform web mining so that we can discover patterns in the web. Or maybe we can do some web scraping. Web scraping is a technique that generally uses the web in order to extract some key features in some web pages. So this is generally using NLP because you have to interpret the context. So we might want to use web mining too. So some general examples and applications of this natural language processing that we have been talking about. Now, what are we going to do as a practice now? We are going to analyze a data set of real observations of Amazon's customer reviews to propose a sentiment analysis approach. So I will be opening the notebook soon. This is going to be our data set. Basically, we have an ID, a product ID, which is related with the product that the customer is talking about, the user ID, the score that the customer is giving to the product, the time where the product that this review was recorded, and the text. This is going to be the review, and this is going to be our key column. So we are going to be analyzing this text column. in order to understand what the customer is talking about the product. So you might be, perhaps you have been visiting the Amazon webpage before. So generally, we have a ton of products in Amazon, and we have these scores. So we have 5 stars. That is why the score is coming from 0 or 1 to 5. And we have some customer reviews. So you can see here in this image that is taken from Amazon that there are 38 customer reviews from a product, and each customer is talking about his experience with the product and is giving a score to the product. So these 2 features, the score and the text, are going to be our most important features to be analyzed. So let's open the notebook. This is going to be the notebook that we are going to be following in this use case. So we are going to perform a sentiment analysis on the reviews of the Amazon's customer products. This is taken generally from Kaggle. The dataset is available on Kaggle too. So imagine you're trying to analyze these reviews because you want to make decisions. So you want to know what the interesting products are. You want to know how to perform this analysis, and you want to make decisions over the products that you are offering in Amazon. So this is going to be our problem statement. What we are going to perform today is basically we are going to read and analyze the text. Second, we are going to perform some basic preprocessing steps, as we have been seeing in the data preparation step. Third, we are going to learn and apply certain featureized review text. So we are going to use certain modelings in order to model this sentiment analysis. And we are going to classify the reviews according to the stars. So we are going to interpret whether the review is talking about positive aspects of the product or is talking about negative aspects of the product. So generally, these are 2 sentiments that we are going to analyze, positive and negative. We have been talking about the NLP context. We already know that there are 2 challenges. We have highly dimensional space, and we have the context, which makes the NLP difficult to understand and interpret at first. So, Chanukia, can you tell me if everything is clear, or are there questions about this general introduction?
I think so far there are no issues. I'm following on YouTube as well as here. So far, no questions. I think it's pretty clear. Yeah.
All right. So first thing to do is to import the packages for this data analysis task. We might want to install these packages. If you don't have these packages already installed, we are going to be using NLTK package and Word Cloud package. So you might want to execute this in order to install those packages. We are going to be using the general packages that we have been using before: NumPy, Pandas, Seaborn, Matplotlib. We are going to be using some NLP specific packages such as NLTK, which is a very important package to process the text. NLTK stands for Natural Language Processing Toolkit. We are going to be using this tokenization function. This is just for tokenizing sentences to have the words. We are going to be counting the repetitions and the frequency of each of the words in the sentences and in the reviews using the count vectorizer function. We are going to be implementing TF-IDF, which is going to be explained when we review this notebook. So this is generally a vectorizer in order to change the dimensional space of the words to vectors. We are going to be counting, and we are going to be expressing the words in a word cloud so that we can visualize those distributions of the words in the reviews. From the modeling aspect, we are going to use the same train test split function in order to split our dataset into training and testing. We are going to be using logistic regression and random forest classifier. So you have been interpreting and playing around with these 2 classifiers. So I guess there is not going to be any trouble when implementing logistic regression and random forest classifier. And we are going to be measuring the performance of our model using the accuracy score and the F1 score. So these are generally our features in the dataset. we have again the product ID, which describes the product, the user ID, which describes the user, the profile name, which is the name of the user, two helpfulness indicators, which denote how helpful was the review from the user, the score that the user is giving to the product, the timestamp of the review of the user, a brief summary of the review, and the general summary, the general review of the user. So the most important features for us are going to be this text, which is the complete review, and this score, which is the score, the rating that the user is giving to the product. Those are going to be our very important features to analyze. The data set is in here in GitHub, so you can access the GitHub account and download or play around with this data set. This is the general data set, just as the slides were stating. We have the text and we have the score, which are the most important features for us. We might want to perform some basic exploratory data analysis so that we can analyze the frequency of the words in each of the reviews. So this is generally accessing the text and applying a lambda function so that we split by spaces each of the reviews and we can get the words. And then we are counting the number of words per review. And we are drawing that words into a histogram with 100 pins. So this distribution of the words look like the following histogram. So we are seeing here that this is pretty skewed positively, and we have a mean of about 77 words per review. So almost all the reviews have less than 200 words. So this is going to be very important for us because we have to analyze the reviews and we need to know how this dimensional space is looking like. So 200 words per review as maximum and 77 words as average per review. We might want to see what the distributions of the scores are. So generally 61% of the reviews are cataloged as 5 stars. So the users are cataloging 61% of the products as 5 star. 14% of the products as 4 stars, 9% as 1 star, 8% as 3 star, and 5% as 2 stars. So we are going to be playing around with this qualification, with these scores of the products. This is just the bar plot. It is the same as seeing these percentages into the bars. So I'm going to jump into the word cloud. The word cloud is very important to us because it's letting us to see what the distribution of the text is in a visualization way. So we are seeing here generally a visualization approach of the words. And this is called a word cloud because we are generally having the words distributed on this square of the word cloud. And once the frequency of the word is high, it means that the word is gonna appear here as big. If the word is big, it means that the frequency is high. If the word is small, it means that the frequency is low in all the reviews. So we can see here that almost all the reviews are talking about products, about flavor, about taste, about coffee. So we might think about the products that the users are reviewing. So generally the products are related with food. So that is why we are talking about flavor, taste, coffee, etc. We are seeing here that are not common words. So we might be thinking about this BR. So BR doesn't represent anything in English. It represents something in HTML language, which is the break. So we might want to analyze why this BR is appearing in our word cloud. For example, these two might not give us some insights about the reviews as the flavor does. So we are thinking here about words that are not telling us insights about the reviews. So we will be coming up with techniques to delete or to drop these words that are not telling us anything about the reviews. And this is important in NLP. We are generating this word cloud using the word cloud package. We need to specify the font size for visualization purposes, as well as the max words. So you can see here in this word cloud that there are 100 words, big or small, there are 100. the background, which is white, the scale, which is going to be how big or small are going to be the letters and in computation, and the width and height of this drawing of the word cloud. And we use the generate function to generate this word cloud using our entire reviews. So we are basically joining all the reviews so that we can have a general string with all the reviews in our data set. Then we make a figure using Matplotlib, and then we show this image with IM_show, the word cloud, and this interpolation bilinear is for making the displayed image appear smoothly. So the words are going to be smoothly presented in this word cloud. We delete the axis because this is not a plot, this is an image, and we show the image. So we obtain this word cloud in here. The word clouds are very important, again, because this word cloud is letting us know what the distribution of the text is. Then we are going to perform these data preparation steps. So generally, we will be standardizing the ratings in order to have the sentiment. So what is going to be our sentiment? Ratings from 4 to 5 are going to be mapped to 1. And this is going to be representing the positive reviews. So the positive sentiment is going to be associated with reviews with 4 and 5 stars. And reviews with 1 and 2 stars are going to be representing negative reviews. So all the comments and text related with stars of 4 and 5 are going to be positive for us. And all the comments rated with 1 and 2 are going to be negative to us. The ratings of 3 are going to represent neutral reviews, and we are not going to take this into account. So we are going to make a sentiment analysis over positive reviews and negative reviews. We can achieve that using the work function of NumPy. This work function basically is filtering and representing these stars into 1 and 0. So we are telling here that the score, if the score is greater than 3, we represent that as a 1. And if the score is less than 3, we represent that as a 0. And then we filter the reviews with 3 score, because those are neutral reviews, and we don't care about neutral reviews because we will be analyzing positive and negative reviews. We can see here that almost all the reviews are positive, less are negatives. We are not going to be addressing this class imbalance issue. Instead of that, we are going to propose some robust metrics as the F1 score. Let's jump into the pre-processing step.
Yeah.
So tell me.
Julian, one quick question. I'm sorry to interrupt. So we have few questions on YouTube. Should we take a practical break now and address them, or do you want to finish the pre-processing and then?
No, tell me.
Yeah. So basically, which technique to use in which area with respect to Spacey versus NLTK?
All right. Generally, we'll be using NLTK, although we can use other packages such as Spacey, as you're talking about. It actually depends on the context, as you're saying. So NLTK is easier to understand. Spacey is more theoretical and more deep. So it will be a little difficult to understand at first. So that is why we are using NLTK at first. NLTK is letting you pre-process all your data and propose some modeling steps. So it should be enough for proposing NLP approaches.
Okay, great. And what does the skewness value define?
All right. So this skewness value is basically defining how asymmetric is our distribution. So you can compare this distribution to a normal distribution. So you can imagine the bell in here, and you can see that the bell is being aligned to the left. So this is not a bell anymore. This is a distribution that isn't aligned to the left. So that is called a positively skewed distribution because it is not related exactly to our normal bell, but is aligned to the left. If the distribution is aligned to the right, we say that this distribution is negatively skewed. So this is just expressing how asymmetrical is this distribution against the Bell distribution.
Right. Got it. Yeah. And interpolation is equals to bilinear. What does this mean?
All right. So in the word cloud, if I delete this parameter, I would have the word cloud, but the words are gonna be not as smoothly as they are now. So we are basically trying to show the words more smoothly. And this is why we are interpolating. Basically, you can drop this parameter and you will see the word cloud, but less smoothly.
Okay. So basically we can experiment, right? Like, by
Yeah,
removing
you
it
can
and yeah.
experiment and you're
Yeah.
gonna see more or less smoothly,
Yeah.
basically.
Got it. And there is one more question. I'm not sure if we should be addressing it now, but I'll just ask it. How do we handle the news data for sentiment analysis? For example, in case of economy related news, there is no rating available. So how to find out positive and negative labeling?
Oh, that is a very good question. So
Hmm.
please remember that we are going to be performing sentiment analysis. And to perform this sentiment analysis, we are going to be using supervised learning algorithms. So it means that you have to know what the target variable is. If you don't know what the target variable is, then you'll be implementing unsupervised learning techniques, and you'll be changing this logistic regression and random forest approaches that we'll be reviewing later. And you
Yeah.
might be want to change that into maybe some clustering on or other approaches of unsupervised learning. So that is going to be the difference.
Right. Got it. So it is completely different, which is slightly out of scope at the moment, if I'm not wrong. So
Yeah.
yeah. Yeah. Great. Perfect. You can go on. Yeah. Thanks.
All right. So once we have a basic, I would say a basic picture of our data. This is just an exploratory data analysis. We want to perform the pre-processing step. So we are going to focus on the data preparation step since it's one of the most important steps to be done in NLP. So there are generally 4 the steps, although you can perform several extra steps. We want to convert the words into lowercase or uppercase so that if we have repeated words, so let's say we have run and run and run. So these words are going to be the same, but the spelling is different. So we want to address that problem and make these 3 words to look the same. So that is why we are converting everything to lowercase or uppercase. Second, we are going to be removing special characters since, for example, if you have run, then you want to interpret the word rather than the special character. So that is why we might want to remove these characters that aren't telling us anything at first sight. Third, we want to remove stop words and high-low frequency words. So, for example, this BR word, which is not telling us anything regarding the English context. It is telling us maybe some insight about HTML, but we don't want to analyze HTML. We want to analyze customer reviews. So this word isn't telling us really anything and isn't giving us insight. So we want to skip those words. And 4, we want to stem and lemmatize so that run, running, and all the verbal expressions look the same. So we want to interpret that we are running or that we run. Everything is going to be the same because it's the verb that we want to analyze. Those are the 4 key steps that we generally need to perform when we talk about pre-processing steps in NLP. So first, how to convert the words into lower uppercase. This is very straightforward. So we have the column. This is going to be our series, which is the text. We access the string parameter, and we convert everything to lowercase. So we have a series, which is called a review text new, and every word is going to be in lowercase. So we are accomplishing this first step. Then we might want to tokenize the sentences into words. So this is one of the simplest examples. So we are using the word tokenize function of NLTK toolkit. So imagine that we want to tokenize DeFi bootcamp rules. It is awesome, which it is in fact. And we want to tokenize this sentence. So if we tokenize the sentence, we want to have the words separately. So please be aware of these special characters, since the point is going to be another word for us. We don't want to have these 2 points in here, so we want to perform some stop words and some low frequency words deleting in the below steps. And please be aware also of this character. This is denoting a sort of emoji. So we are not gonna be seeing here emoji analysis and pre-processing, but please be aware of this, because this D isn't gonna give you any insight and might be biased. So you want to delete these type of characters too. So what is the difference of applying this first step? So this is the amount of words without applying the lowercase step. So we can see there are 27,000 words. And after applying this lowercase step, we have 22,000 words. So it's a reduction of almost 18%. So it means that 80% of the words were expressed differently in spelling, but the meaning is the same and the word is the same. So we are reducing this bias by applying the lowercase transformation to the words. It is generally called normalizing. So we are expressing all the words in a standard and normalized way, which is the lowercase. Second, removing the special characters. So once we have transformed our text into lowercase, we might want to remove some special characters that aren't going to give you insight. So how are we going to do that? This is going to be our series, which is the series of the lowercase transformed text. We are going to apply a function. This is going to be a list comprehension, which can be transformed to a non-list comprehension approach, where we are iterating over each of the characters of the review. And if the character is not alphanumeric and is not space, we are not going to address that. So you can see here after this approach that we have plenty of special characters in all of our reviews. So there are characters such as apostrophes, numerals, and everything that aren't going to give us insight. So we might want to drop or delete these special characters. How can we do that? So this might be a complex code at first. So this are going to be our series. This is our series, review text. This is the string value. So we want to access the string reviews. And we want to replace using regular expressions. So what this regular expression is stating is that we might keep the letters in uppercase, the characters in lowercase, and the numbers, including the space. Everything that is not in this set is going to be rejected. So we can see here an example. The previous review was this one. So you can see here some apostrophes, some points, some exclamation signs, and other type of signs such as comma. And after removing those special characters, you can see here in this review that there are no apostrophes and other characters anymore. So every special characters is being replaced with a space. So this should be our review to be analyzed. So we are gonna achieving those steps of transforming to lowercase and removing special characters so that every word in this new review is gonna give us some insight. So you can see here that originally there were 27,000, and after transforming to lowercase and removing special characters, we have 18,000. So we have been removing a lot of words that aren't going to give us insight. Third step, removing stop words. So what are these stop words? Generally are words
Julian,
that are, yeah, tell me.
I'm sorry. So there is a quick question here on the character. Okay. So basically coming to the special characters, right? There is this question, but if we remove the special characters like exclamatory mark, it may change the meaning of the word. That is what exclamatory mark and what question mark. So if you're saying what with exclamatory mark, there is a difference, right? And whereas where you're using what with a question mark, it might have a different meaning. So what kind of impact it will have in the entire scheme of things?
Yes,
Yeah.
that is totally context dependent.
Yeah.
So as I was stating in here, you might want to see exactly that those special characters are giving some extra insight to you because of the context. So you might want to keep them, and
Right.
you might want to address that issue too.
Right.
If
So
the
you,
context is letting you
yeah,
analyze some extra insights from the special characters.
true. So you can technically customize it and
Yeah,
write it
totally,
accordingly.
totally.
Yeah.
Yeah.
Yeah. Okay.
All right. Is there any other question?
No, I think this is pretty much about it. I think we are pretty clear apart from that. And okay, yeah, that's it.
All right. So the stop words again are words that might be highly or lower frequency in our reviews, but that are not going to give us insights such as prepositions and adverbs and other words. So first of all, let me say that when you are using NLTK, there are plenty of languages that can be taken into account, such as English, Spanish, Arabic, and other languages. Um, there is no Indian language in here, but there is a package that address for this special language, which is the INLTK package. So you might want to use the INLTK package to process in the reviews, which is possible as well. So don't worry if the language is not appearing in this list. There are other packages that address for these special languages. Um, so we are gonna be using English language. So we wanna import the English language as well. So you can see here that there are plenty of stop words in English. Most of them are adverbs, prepositions, and other type of words. So for example, if you talk about she, or you talk about it, or you talk about and, or you talk about is, they are not gonna give you much insight about the review. So you might want to discard those words. I might say that although these stop words are defined for English, you can customize this list. So for example, if you is a very important word for you and is giving you insight because of the context, you might want to keep this word. So you can delete this word from the general list of stop words as well. So this is just a guide for you of general words, but you can customize these stop words as well. So the next step is removing those stop words from our reviews. How are we gonna do that? Basically, we are gonna be following this approach. We are gonna be removing the stop words just in the review number 0 for this example. And we are gonna state this for loop so that if the word is in the stop words list, we are gonna add that word to one list. And if the word isn't in the stop word list, we are gonna add that word to another list. So we are gonna have stop word lists in our review and non-stop word lists in our review. So you can see here that this was the original review from the user. Once you have transformed this review to lowercase and removed the special characters, and the stop words in the review are these ones. So these are the words that match with the stop word list of stop words in NLTK. So you can see here that we have I, that we have half, of, the, etc. And the non-stop words in this review are these ones. So technically, these non-stop words should give you more insight when analyzing the words than these stop words. So that is why we are removing this list and we are maintaining this list. So it isn't the same as analyzing and as analyzing, for example, several, or analyzing good, for example, which is going to give you a lot of insight when analyzing the review, because the customer might be talking about a good product and this and is just not going to give you any insight. This is a general function of removing stop words that you might want to use. So this is a list comprehension. Once you have transformed your sentence into words, you might want to keep the non-stop words, and this is going to return a list of non-stop words of all of your reviews. So you can see this approach applied in our dataset. This is the original review once we have transformed into lowercase and delete special characters. and this is the list of non-stop words. So you can see here that there are no prepositions and adverbs anymore. We have almost 9,000 of reviews of observations of products in our data set. So be aware of this number because this is already very high number. The fourth step is going to be the stemming and lemmatization step. So I'm just gonna skip this explanation for giving you an example. So we are gonna import the Porter stemmer and Lancaster stemmer, which are two different stemmers that are doing broadly the same task. And we are gonna be applying a WordNet lemmatizer. So let's look at an example. If you apply this stemmer to these three words, so we have a verb in different expressions. We have traveled, traveling, and traveled. If you apply a stemmer, you can see here that you have the inflection of the word. So you have trouble. So you might think, okay, although this is an inflection of the word, it isn't giving me much insight because this is not a word in English. So there are some certain difference in stemming and lemmatizing. So the lemmatizer is giving you the root of the word. So you can see here that we have travel, traveling, and travel, and we have the root of the verb, which is travel. We are using the WordNet since we are telling the lemmatizer that we have here a noun, we have here a verb, and we have here a verb. So the lemmatizer should extract the root of these three representations of travel. And in fact, is extracting the travel representation. So this is the difference between the stemmer and the lemmatizer. So you might want to apply lemmatization because generally traveling and travel is coming from the same travel representation. So you want to analyze travel instead of different expressions. Once we have applied this 4-step procedure, once we have transformed to lowercase, we have deleted the special characters, we have removed the stop words, and we have stamped and lemmatized our text, we can apply a machine learning model. So we have done the data preparation step, we have already done the exploratory data analysis. Now we can skip all the processes and we can go to the modeling stage. What are we gonna model? So we have the text, we have the score, and we have the sentiment. So please remember that this is a supervised learning approach. So we have already got our target variable and we are gonna apply some classification models into this target variable. One important task to be noted here is the Engrams. So we have been working with words, but we can work with some additional representation of these words. So we have been working with 1-grams, which are the separate words, but we can join those Engrams into different words representation. So for example, we have this is a sentence, which is a sort of 4 unigrams joined. But we have bigrams, which are 2 words joined. So our first bigram is going to be this is, our second bigram is going to be is a, and our third bigram is going to be a sentence. Or we can have 3 words joined. So our first word is going to be this is a, and our second trigram is going to be is a sentence. Or we can have 4 grams. So we are just having 1 4-gram, which is going to be this is a sentence. So this is very useful because when we analyze words separately, we might be biased or we might not be interpreting the complete picture. If we analyze words together, the one that is coming after and the one that is before of my word of interest, we might have some additional insights of our reviews. What is the advantages of this? Because we are retaining the structure, we are not transforming, and we are not altering our nature of our data. And we might have more insight about the context that is related with the reviews. What is the great disadvantage, the huge disadvantage, that the dimensions are large. So if you include bigrams, then you're gonna have a lot of features. If you include trigrams, then the features are gonna be more. So you have to balance between this approach where you have a lot of features and the computational expense of processing these features. So Engrams are going to give you more context, but also are going to give you more computational expense. So let's see another example. I have this, a bird in the hand, words 2 in the bush. So if you extract 1 grams, they're going to be simply the words. If you extract B grams, they're going to be 2 words that are next one to each other. So we are going to have a bird in the trigrams are going to be 3 words next to each other, 4 grams, 4 words, 5 grams, 5 words, etc. All right. So once we have understood that, we can come up with a bag of words. This bag of words is based on a technique that is called the count-based representation. So we are representing the words in counts. So we are counting basically the words in the reviews, and we are constructing a matrix. So how is this matrix looking like? It is looking like this matrix that we have in the notebook. So you have all your reviews, which are going to be your observations, your rows, and you have the unique word representations as columns. So each word that appears on the review is going to be counted on each of the reviews. So you might want to think about the complexity to analyzing this. So we have 18,000 of columns to be analyzed per observation. So in total, this matrix, which is called a sparse matrix because it has all the counts of the words in the reviews, has 9,000 rows in total and 18,000 columns. So this is going to be very difficult to process and very, very computational expensive. How can we create this rapidly? Basically, we can count. This count vectorizer is constructing a vector with the counts of the words in each of the reviews. We are passing the function of tokenizing the words so that the sentences can be tokenized into words. We are passing as input the stop words so that this count vectorization can remove the stop words. And we are passing the Engrams. So we are going to be handling just words. And then our common function, which is the fit transform. So we are fitting and transforming the reviews. And we see here that we have 9,000 rows, which are our observations, and 18,000 columns, which are going to be our words. So this is a lot to be processed. Once we have this representation, so be aware that this is a numerical representation. So this sparse matrix has just numbers, just counts of the words. So once we have that, we can extrapolate this approach into a featurized approach, where each of the column is one feature and each of the rows are observations. So now we can train a model and we can test a model. So we apply the traditional train test split function with our features. This is sparse matrix is going to be our feature matrix, and our target variable is going to be the sentiment rating that we have defined before. We might want to have 20% for testing and a random state of 0 for replication purposes. So once we have splitted our dataset into training and testing, we can train a model. So we can apply, for example, a logistic regression approach. So we build a logistic regression object. We feed that object using our training set, which is coming from this training and testing split, and the Y train, which is going to be our target. Then we can predict over the test, and then we can calculate the metric, which is going to be the F1 score because of the class imbalance approach. And we can see here that we have a 95% of F1 score, which is considerably high. So we are approaching our NLP problem into a classical modeling approach. So this is just very classical for you, and you have been interacting with this type of cells before a lot in your assignments. So this is just defining a classification model. Once you have processed your data, which is the text, into sparse matrices or other type of representations. So the tasking here is not about the modeling stage, but about the data preparation stage. All right. So we can play around with the function. So we can count, and instead of counting words, we can count bigrams, trigrams, and 4 grams. That is why we are changing this into 4. So we now are accounting about bigrams and trigrams and 4 grams. And we can apply again the same approach, which is the training and test split. So I want to give you this insight because look at this column space. So once we have been processing words, we have 18,000 columns. If we include bigrams, trigrams, and foregrams, you can see here that the sparse matrix now have 1 million rows to be processed. So including these engrams is increasing the feature space. And then it's going to be increasing the computational expense. So again, we split our dataset into training and testing. And again, we can apply a logistic regression approach. Just as before, we can predict and we can find the F1 score. And we can see here that the F1 score is slightly higher, about 95.4%. And before it was 95.3%. So you have to balance your computational expense from coming of 18,000 features to 1 million features against less than 0.1% of increment of increase in your F1 score. So you have to balance those features. This is very interesting because now we want to extract which are the most important words for us and for the classifier in order to classify the reviews into positive and negatives. So you can see here that these are the top 15 words for the classifier to classify into positive reviews. So words such as great, delicious, perfect, good, the best, excellent are driving your classifier to classify the entire review into a positive review. And this has a lot of sense, as well as the negative reviews that have words such as worst, stick, awful, waste, bad, weak. So this also has a lot of sense. So these are the words that are driving your classifier to classify the reviews into positive or negative. Now that we have applied this bag of words approach with a logistic regression modeling, we can change that approach into a TF-IDF approach. This model accounts for the repetition, the frequency of the words, and times a logarithm of the total number of documents of reviews divided by the number of documents containing the word that you are counting. So this is basically the same approach as bag of words, including another term that is accounting for the logarithm of something else in here. I don't want to explain the math behind this. What I want to explain is that this is another approach that accounts for the frequency of the words plus something else. So we can implement that model using the TF-IDF vectorizer instead of the count vectorizer. The input is going to be the same, the function that tokenize the words, the stop words, and the engrams, which is going to be our simple words. And we can free transform that tokenizer, that vectorizer, and we can train test split, and then we can apply a logistic regression model again using the TF-IDF matrix. You can see here that roughly we have the same columns because we are applying the same approach of counting times some logarithm extra. So we can test again the model using the F1 score, and we have 94% of F1 score. So in this case, we have less score than before. So sometimes it happens. Sometimes TF-IDF is a better approach. So be aware of the context because this is going to be very context dependent, and you'll have to customize all of these approaches. And finally, we have a third approach, which is going to be the word embeddings. So this is a different approach because we are transforming our text, but considering a limited feature vector. So we are not going to get 18,000 features, but we are going to get a limited number of features. This is a number that we propose. So how can we do that? I'm going to skip this explanation for the moment. How can we do that? So please be aware of this code. This code is commented. It's commented because of a reason. It's going to take a lot of time for processing because the reviews are large to be processed. So how can you build this approach? So instead of having 18,000 features, we are going to limit that feature space into 200 so that the computational expense is less. So this is very important of word embeddings. How can we do word embeddings? There are plenty of techniques. Yeah, tell me, Chanka. I think microphone.
No, Chanakya has gone for the moment. I have some doubts on the YouTube channel. If you can take them up now.
Yeah, sure.
Yeah. So someone asked, will logistic regression hit the curse of dimensionality here?
All right. So yeah, we have to be aware of the dimensionality issue in here because there are a lot of features to be analyzed. So that is why actually we are proposing these word embeddings in order to have a less dimensionality space that we can analyze better.
Okay. Um, Another question is, what does zip do in the code?
All right, that is a Python-based question. So I think we can explain those questions later. Basically, the zip is associating each of the features in here with each of the coefficients in the logistic regression. So we have basically two lists, one with the features and one with the coefficient, and we are associating one word with one coefficient so that we can plot this representation of a data frame.
Okay. Okay, so there's one use case question of how do we handle the max DF for features in case of TF-IDF when the data set is imbalanced? Because usually the event rate will be low in this case.
All right, so we are not accounting for class imbalance because it would be an extra code, but generally you can apply the classical approaches of feature selection and class imbalance such as SMOD or any other approach. So it doesn't matter if you're talking about NLP because you have a sparse matrix and you can apply the SMOD transforming as well.
Okay. Okay, I guess that's it with the questions for now. You can continue.
Thank you, Gunika. All right. So again, the third approach is going to be the model embeddings so that we can reduce this feature space of 18,000 words into a 200 representation. So that is why we are executing here this code with this parameter. So our space is going to be a 200 dimensional space instead of an 18,000 dimensional space, such that we can account for this dimensionality issue that we might have. How can we do that? Using different approaches. So there are plenty of approaches and algorithms such as the word2vec, the globe, the fast text, the spectral embeddings, UMAP, and other approaches that we might use. So in this notebook, we are not going to execute this code because it's going to take a while, but we are going to use a pre-trained model. So we are going to use the Twitter Globe pre-trained model, which contains a lot of words represented in a 200 dimensional space. If you want to generate this pre-trained model, you can execute this cell with all the Twitter reviews, and it's going to give you the exact same model. So because of time and because of computational expense, we might don't want to execute this cell. Basically, we are loading the Twitter Globe pre-trained model, which contains 200 features per word. And we are going to use that model in order to transform our reviews to that 200 feature space. So you might want to see some examples in here. So for example, the word food has a 200 feature representation. As you can see here, there is a 200 dimensional vector or a one-dimensional vector with 200 features. It is the same. Words such as grade, the same, 200 features. So every word is going to have 200 features, and you might want to process those words in your reviews of Amazon. So that is what we are going to do here. So in this cell code, we are joining that pre-trained model and that word representation to our reviews so that we can have 200 features per observation, so per review. So this I'm not going to explain this code deeply. Basically, we are extracting the average of the representation of that 200 dimensional space, and we are joining our text with the pre-trained model. So we end up with this matrix in here, with this data frame. So you can see here that now we have 200 columns, which are going to be our 200 feature space, and we are keeping the 900 rows. So these are going to be our observations, our reviews, and now their reviews are being represented with 200 columns instead of 18,000 columns. So this is a notable reduce in computational expense. So once we have this representation, we can implement again a classifier. So we might want to think of applying again a logistic classification approach. So we train test split again with this feature vector. We have the target variable, we have the test site and the random state. Then we feed our logistic regression model and we predict and calculate the F1 score, and we get 92% of F1 score. So this is lower than before, but please note that we are reducing 18,000 to 200. So that is a lot of reduction in the feature space. So of course, our performance is going to be affected because this is a less dimensional space of features, but our computational expense is going to be greatly decreased. So please note this balance between the computational expense and the F1 score. So this is generally the approach that we follow when we process NLP and when we do sentiment analysis. Basically, we are building a model based on the features, and now we can predict using other comments what the sentiment of the user is. So if you post another comment, we can predict with a 92% of F1 score what your sentiment is, if it is positive against the product or negative against the product. So basically, that is the goal accomplished using this analysis. So in conclusion, we can say that we have been processing a lot of text and we have been representing that text in different ways. So the key aspect to take into account in here is the computational expense against your performance. So you'll have to balance those two in order to get the best model for you. Not everything has to be applied in each case is another conclusion. So you might want to skip some steps, and that is going to be correct. It is according to your context. You might want to customize some steps, and that is also correct because it's related to your context. And you can extrapolate this analysis into several fields using NLP, reviews, for marketing, for production, for advertisement, whatever the context is. And the analysis of the language components through this natural language processing is allowing us to make decisions and to implement and deploy some additional models so that we can analyze what the sentiment of the customer is when he is writing reviews of a product. So we can make decisions with this new approach that we are implementing in several contexts. Some additional research that we have been doing using NLP so that you can see that although this is sentiment analysis, it can be implemented in several contexts. We have been doing sentiment analysis on customer reviews of mercadolibre.com, which is another similar to Amazon, but for Colombia. So we are implementing the exact same approach, but using Spanish language. We are implementing a sentiment analysis algorithm for political control on Twitter so that we can see the interaction of politicians with the audience. We are implementing NLP to digital forensic analysis so that we can get some insight about the file modifications and mobile modifications. And we develop an algorithm for PQRS processing of the users. So you can extrapolate this sentiment analysis to almost all the contexts where the text is related. So again, the horizon is open to you. Although we are at the end of this session, there are plenty of approaches to be implemented, and you can join all your classification and regression techniques that you have been learning in this bootcamp to another context so that you increase your portfolio and you effectively do these data science approaches. So thank you, your audience and Defi for having me.
Great. Thanks a ton, Julian. I think it was a very thoughtful and very insightful session. Thanks a ton for that. Before we close on, we have a couple of questions. Performance-wise, which one we need to use? Genism, count vectorizer, TF-IDF.
All right. That's a very good question. Actually, it depends again on your context. So there's a very good question of some of you regarding the segment 3, because you have been implementing a lot of models, which is absolutely correct. So that is the same approach. If you implement random forest, logistic regression, XGBoost, and a bunch of other models, it is the same approach here. So you might want to implement several models in order to learn about the context and in order to have different insights. So this is a very testing procedure and sometimes empirical, and you might want to test several ways in how to interpret the text.
Okay, great. The next question is, what if we apply PCA on the model with Engrams up to 4? So for PCA is nothing but, okay, yeah, I'll let you answer it. Yeah, go ahead.
Yeah. I didn't want to get to that, but here is a representation that is considering PCA and t-SNE. So that is accounting for dimensionality reduction, and you can apply it so that the 200 dimensional space can be represented into a 2-dimensional space, such as the following that is here. That is also valid. But please remember that once you have reducing your feature space, also the performance might be reduced as well, because you have less data to represent your text. So there is always the balance of performance against the computational expense. So you will need to find that balance.
Yeah. Okay. Yeah, and I think, like, coming to PCA, we didn't really discuss during the boot camp, but just for everyone's understanding, it's a dimensionality reduction technique. Yeah, it's called as principal component analysis. And yeah, we have third question. Do negative numbers means those words drive the data set for negative review?
Yeah, exactly. So if you see here, these positive numbers, which are sorted, are driving the classifier to positive reviews, and these negative numbers are driving the classifier to negative reviews.
Great. Yeah. And I think we are pretty much done with the questions. We are, I mean, like, we are seeing a lot of thank you messages pouring in on YouTube. Uh, and yeah, I think we have one more question before we close on. How about reducing the dimensionality using something like PCA and creating a model? It's more or less the same question, I guess. But yeah, basically we limited the scope of the session, right? We didn't really explore on that vertical, if I'm not wrong. Julian, please correct me.
Yeah. So
Yeah.
what we are doing here is just transforming our text into a vectorized representation where we count the words and we transform them into features. So once you have done that, for example, if you apply this fast text and you've got 200 features, you can apply dimensionality reduction to that data set so that those 200 featured dimensional spaces, you can reduce them into a 2-dimensional space, and you can represent the features with a bidimensional space like the following, so that you can plot the words basically into this bidimensional space.
True. Yeah, great. Thanks a ton, Julian. I think, like, it was a wonderful session. I think the comments that are pouring on across talks volume about the kind of session that was delivered. Thanks a ton for yet another wonderful session. And also thanks to Raviraj and Gunika on the other end, who were trying to address the questions on YouTube channel. Yeah, thanks a ton for that. Anything that you want to add, Julian, on a final note? And also, this today is supposed to be the final day of the boot camp, and also we are done um, with the submission phase as well for assignment 3. And just to give some heads up, to all the learners, we'll be having a Kaggle in class competition and a few other things, few other exciting things which will be coming going forward very soon. We will make some announcements on that front very soon. But before that, I would want to like, Julian, you can add some words, probably your thoughts on the boot camp, and also what is the kind of messaging that you want to give to the learners from here on?
Yeah, you have been doing awesomely. I mean, I'm greatly surprised about the questions and the queries and the enthusiasm of you guys, the learners, coaches, and teammates. It has been awesome for me to be in this bootcamp. I have learned a lot from you. I mean, although I am in a coach role and status, I'm also a learner. I am learning from you, learners, coaches, and teammates. So I'm greatly surprised about all this enthusiasm and all these friendships that you have made in the bootcamp. So this is just amazing to me. I'm truly amazed and greatly surprised, and I have been loving all of the messages and all of the activities that you have been doing, and you have been doing greatly. So congratulations on DeFi, and the learners and everyone who is behind the hood and behind this type of tasks, because you have doing awesomely.
Great. Thanks a lot, Julian, and thanks for the name correction, DeFi, and
Yeah.
thanks for that. And also, I think I totally second that the kind of enthusiasm that we have seen over the last few weeks, and especially the last few days, the kind of improvements that they have shown in terms of optimizing their models and bunch of other things. It is truly amazing. And also, I think. Yeah, for those who couldn't make it, or who are thinking that we were not in top 10 or top 15, that's completely all right. I mean, it's not a competition, to be honest. And when we come into the real industry use cases, sometimes we compromise uh, on the metrics as well, just because of a few factors. Like, we would want to run the model quickly or efficiently in a shorter span. And also sometimes we also go with feature selection. I mean, we pick very few features so that the models run quicker, and also for explanation it is better in some cases. So sometimes we do take some compromises somewhere. So the parameters that we have defined, yes, I mean, it probably puts some of the learners on forefront and some at the back foot, but that doesn't define anything. And you have learned a lot in the last 5 weeks, and I think it's just a nice testimony overall, the kind of performance that you guys have produced in the last few days. Thanks a ton for that, and stay updated for the upcoming new surprises that we would have for you all. And we are quite excited about it, and I believe you'll be excited about it too. And thanks a ton for joining us. Take care. Yeah, bye everyone, and thanks, Julian. Thanks a lot.
My
Bye.
pleasure. Bye.